Good morning everyone. I am Parkavi, working as Assistant Professor of Mathematics in Erode Engineering College. Now we discuss about the topic differentiation of vector. First we discuss about the introduction of this topic. In this unit we are going to learn about the basics of vector calculus, comparison of gradient, divergent and curl and line, surface and volume integral which plays an integral part in engineering subject. Next definition is point function. A variable quantity whose value at any point in a region of space or depends upon the position of point is called a point function. Next definition is scalar point function. A scalar point function is a function that assigns a real number to each point. That means the real numbers are x, y, z of a region or in space there is assigned a real number u is equal to pi of x, y, z. Then pi is called a scalar point function. For example, the temperature distribution within some body at a particular point in time. And the second example is the density distribution within some fluid at a particular point in time. Next definition is scalar field. A scalar point function defined over some region is called a scalar field. A scalar field which is independent of time is called a stationary or steady state scalar field. A scalar field that varies with time would have the representation u is equal to pi of x, y, z, t. And the next definition is a vector point function. A vector point function is a function that assigns a vector to each point of some region of space. If to each point x, y, z of a region or in space there is assigned a vector capital F is equal to capital F of x, y, z, then f is called a vector point function. So we denote capital F is equal to f1 of x, y, z into I vector plus f2 of x, y, z into j vector plus f3 of x, y, z into k vector. Or we defined another way, capital F is equal to f1, f2, f3 is equal to f1 of x, y, z, f2 of x, y, z, f3 of x, y, z. For example, gravitational field of a earth, electric field about the current carrying wire, magnetic field generated by a magnet, velocity at different points within a moving fluid, acceleration at different points within a moving fluid. And next definition is a vector field. A vector point function defined over some region is called a vector field. A vector field which is independent of time is called stationary or steady state vector field. A vector field that varies with time would have the representation capital F is equal to f1 of x, y, z, t into I vector, f2 of x, y, z, t into j vector plus f3 of x, y, z, t into k vector. Next definition is a scalar point function. At each point P of a region R, we may associate a scalar denoted by pi of P. We then say that pi is a scalar point function over the region capital R. And the next definition is a vector point function. If to each point P of a region R, there is associated a vector f vector of P, then the function capital F vector is called a vector point function. Next definition is a gradient. A vector differential operator delta. The vector differential operator delta is defined as capital delta is equal to I into dou by dou x plus j vector into dou by dou y plus k vector into dou by dou z, where I vector, j vector, k vector are unit vectors along the three rectangular axes ox, oy, oz. And the next topic is the gradient or slope of a scalar point function. Let pi of x, y, z be a scalar point function and is continuously differentiable, then the vector del pi is equal to I into dou by dou x plus j into dou by dou y plus k into dou by dou z into pi. So multiply pi. So we get I vector into dou by dou x plus j vector into dou pi by dou y plus k vector into dou pi by dou z is called the gradient of the scalar function pi and is written as gradient pi is equal to del pi. The notes are del is the vector differentiable operator and also it is a vector. delta is equal to summation I vector into dou by dou x. That means it can be written as I vector into dou by dou x plus j vector into dou by dou y plus k vector into dou by dou z. Del pi is a vector whose three components are dou pi by dou x, dou pi by dou y, dou pi by dou z. If pi is a constant, then del pi is equal to 0. Del pi should not be written as pi del because del pi and pi del are not same. There will be no dot or cross between pi and del. Del of C1 pi 1 plus or minus C2 pi 2 is equal to C1 del pi 1 plus or minus C2 del pi 2, where C1 C2 are constant and pi 1 pi 2 are scalar point functions. And next one is del of pi 1 pi 2 is equal to pi 1 into del pi 2 plus pi 2 into del pi 1. Next one is del of pi 1 by pi 2 is equal to pi 2 into del pi 1 minus pi 1 into del pi 2 by pi 2 square, where pi 2 is not equal to 0. If v is equal to f of u, then del v is equal to f dash of u into del u. Next one is del of f plus or minus g is equal to del f plus or minus del g. We know that r vector is written as xi vector plus yj vector plus zk vector. And r is equal to modulus r vector is equal to square root of x square plus y square plus z square. We take squaring on both sides, we get r square is equal to x square plus y square plus z square. So to differentiate, we get 2r into dou r by dou x is equal to 2x, 2r into dou r by dou y is equal to 2y, 2r into dou r by dou z is equal to 2z. And the problem based on the gradient. First problem, prove that the gradient of a constant is 0. That means del y is equal to 0 we have to prove. So use the concept, if pi is equal to pi of x, y, z be a constant, then dou pi by dou x, dou pi by dou y, dou pi by dou z are also 0. So take del pi is equal to I vector into dou pi by dou x plus j vector into dou pi by dou y plus k vector into dou pi by dou z. So here dou pi by dou x, dou pi by dou y, dou pi by dou z are 0. So applying here we get del pi is equal to 0 vector. So the gradient of a constant is 0. And the next one is, if pi 1 and pi 2 are scalar point function, so we have to prove del of C1 pi 1 plus or minus C2 pi 2 is equal to C1 del pi 1 plus or minus C2 del pi 2, where C1 C2 are constant. So del into C1 pi 1 plus or minus C2 pi 2 is equal to I vector into dou by dou x plus j vector into dou by dou y plus k vector into dou by dou z into C1 pi 1 plus or minus C2 pi 2. So multiply C1 pi 1 plus or minus C2 pi 2, we get I into dou by dou x into C1 pi 1 plus or minus C2 pi 2 plus j vector into dou by dou y into C1 pi 1 plus or minus C2 pi 2 plus k vector into dou by dou z into C1 pi 1 plus or minus C2 pi 2. So separate I vector, j vector, k vector, we get I vector into C1 dou pi 1 by dou x plus or minus C2 dou pi 2 by dou x plus j vector into C1 dou pi 1 by dou y plus or minus C2 into dou pi 2 by dou y plus k vector into C1 dou pi 1 by dou z plus or minus C2 into dou pi 2 by dou z. So C1 take outside, C1 into I into dou pi 1 by dou x plus j into dou pi 1 by dou y plus k vector into dou pi 1 by dou z plus or minus C2 into I vector into dou pi 2 by dou x plus j vector into dou pi 2 by dou y plus k vector into dou pi 2 by dou z. So here del pi 1 is written as I into dou pi 1 by dou x plus j into dou pi 1 by dou y plus k into dou pi 1. So C1 del pi 1 plus or minus C2 pi 2. And the next one is, if f and g are any two scalar point function, then del into f plus g is equal to del f plus del g. So del of f plus g is equal to del is written as I into dou by dou x plus j into dou by dou y plus k into dou by dou z into f plus z. So f plus g, to multiply we get I into dou by dou x into f plus g plus j into dou by dou y into f plus g plus k into dou by dou z into f plus g. So I vector into dou f by dou x plus dou g by dou x plus j vector into dou f by dou y plus dou g by dou y plus k vector into dou f by dou z plus dou g by dou z. So I vector into, so split f and g separately. So we get I into dou f by dou x plus j vector into dou f by dou y plus k vector into dou y dou z plus I vector into dou g by dou x plus j vector into dou g by dou y plus k vector into dou g by dou z. So we get del f plus del g. So del of f plus g is equal to del f plus del g. Similarly, we can prove that del of f minus g is equal to del f minus del g. Can be written as gradient of f plus or minus g is equal to gradient of f plus or minus gradient of g. Next one is, if f and g are two scalar point function, then del fg is equal to f into del g plus g into del f. So del into fg is equal to I vector into dou by, del is written as I into dou by dou x plus j into dou by dou y plus k into dou by dou z into fg. So multiple fg. So we get I into dou by dou x into fg plus j into dou by dou y into fg plus k into dou by dou z into fg. So I vector into, so udv formula. So f into dou g by dou x plus g into dou f by dou x plus j vector into f into dou g by dou y plus g into dou f by dou y plus k vector into f into dou g by dou z plus g into dou f by dou z. So I vector into f of dou g by dou x plus I into g into dou f by dou x plus j vector into f into dou g by dou y plus j vector g into dou f by dou y plus k vector into f of dou g by dou z plus k vector into g of dou f by dou z. So take outside f, we get f vector into I vector into dou g by dou x plus j vector into dou g by dou y plus k vector into dou g by dou z plus take g outside, we get g into I vector into dou f by dou x plus j vector into dou f by dou y plus k vector into dou f by dou z. So del into fg is equal to f into del g plus g into del f. This can be written as gradient of fg is equal to f into grade g plus g into grade f. And next one is, if pi is equal to x, y, z, find del pi. Given pi is equal to x, y, z. So del is written as I into dou by dou x plus j into dou by dou y plus k into dou by dou z into x, y, z. So I vector into dou by dou x into x, y, z plus j vector into dou by dou y into x, y, z plus k vector into dou by dou z into x, y, z. So I vector into dou x by dou x is 1. So we get y into y, z plus j into x, z plus k into x, y. And next one is, if pi is equal to log of x square plus y square plus z square, find del phi. Given pi is equal to log of x square plus y square plus z square. So del phi is equal to I into dou pi by dou x plus j into dou pi by dou y plus k into dou pi by dou z. So dou pi by dou x. So to differentiate pi, we get log x is to differentiate, we get 1 by x. So 1 by x square plus y square plus z square. Again to differentiate x, we get 2x. So 2x by x square plus y square plus z square. Similarly, dou pi by dou y is equal to 2y into 2y divided by x square plus y square plus z square. Dou pi by dou z is equal to 2z by x square plus y square plus z square. So del pi is equal to I vector into 2x by x square plus y square plus z square plus j vector into 2y by x square plus y square plus z square plus k vector into 2z by x square plus y square plus z square. So 2 by x square plus y square plus z square is common. So take outside. So we get xi vector plus yj vector plus zk vector. It can be written as r vector. So 2r vector by r square. And next one is, find del r and del of 1 by r. We know that r vector is written as xi vector plus yj vector plus zk vector. So r square is written as x square plus y square plus z square. So dou r by dou x is equal to x by r. Dou r by dou y is equal to y by r. dou r by dou z is equal to z by r. So del r is equal to I into dou by dou x plus j into dou by dou y plus k into dou by dou z into r. So multiply r inside, we get I into dou r by dou x plus j into dou r by dou y plus k into dou r by dou z. So dou r by dou x values x by r, dou r by dou y values y by r. So dou r by dou z values z by r. So apply here, we get 1 by r is common, so take outside. So xi vector plus yj vector plus zk vector, it can be written as r vector. So r vector divided by r. Next we have to find del of 1 by r. So del is written by, can be written as I into dou by dou x plus j into dou by dou y plus k into dou by dou z into 1 by r. So I into dou by dou x into 1 by r plus a j vector into dou by dou y into 1 by r plus k vector into dou by dou z into 1 by r. So to differentiate 1 by r, we get minus 1 by r squared into, again to differentiate r with respect to x, we get dou r by dou x. The same thing in y and z. So we get I vector into minus 1 by r square into x by r plus j vector into minus 1 by r square into y by r plus k vector into minus 1 by r square into z by r. So minus 1 by r cube is common, so take outside, and the remaining terms are xi vector plus yj vector plus zk vector. It can be written as r vector. So minus r vector by r cube. Or another way we have to prove the same result, del of 1 by r is equal to, we use summation I into dou by dou x into 1 by r. So to differentiate with respect to minus 1 by r square into dou r by dou x. So summation xi vector is written as xi vector plus yj vector plus zk vector. So we get minus r vector by r cube. And the next problem is, the temperature at a point x, y, z in a space is given by T of x, y, z is equal to x square plus y square minus z. A mosquito located at the point 4, 4, 2 desires to fly in such a direction that it gets cooled faster. Find the direction in which it should fly. So given that T of x, y, z equal to x square plus y square minus z. So we have to find del t at that point 4, 4, 2. So first we have to find del t. So I vector into dou t by dou x plus j vector into dou t by dou y plus k vector into dou t by dou z. So dou t by dou x means to differentiate t function with respect to x, we get 2x. So I vector into 2x plus j vector into 2y minus k vector. Dou t by dou z is 1. So del t is equal to 2x I vector plus 2y j vector minus k vector. At that point are 4, 4, 2. So here x value is 4, y value is 4 and z value is 2. So substitute here we get 8 I vector plus 8 j vector minus k vector. And the next problem, if pi is equal to x square plus y minus z minus 1, then find gradient of pi at 1, 0, 0. Given pi is equal to x square plus y minus z minus 1. So del pi is written as I into dou pi by dou x plus j into dou pi by dou y plus k into dou pi by dou z. So I vector into dou pi dou x, pi values x square plus y minus z minus 1 plus j vector into dou by dou y into pi value. So substitute here, we to differentiate with respect to x, we get I into 2x plus j into 1 plus k vector into minus 1. So del pi is equal to 2x I vector plus 2j k vector minus k vector. So gradient of pi, the value is 1, 0, 0. So here x value is 1 and y value is 0 and z value is 0. So apply here, we get 2i vector plus j vector minus k vector. And next one, the same problem, the above problem. Find gradient of pi if pi is equal to x, y, z at that point 1, 1, 1. Given pi is equal to x, y, z. So del pi is equal to gradient pi. So it can be written as I into dou pi by dou x plus j into dou pi by dou y plus k into dou pi by dou z. So del pi is equal to pi values x, y, z. Apply here. So we get y z I vector plus x z j vector plus x y k vector. Here x value is 1, y value is 1 and z value is 1. Apply here, we get del pi is equal to I vector plus j vector plus k vector. Find gradient f if f is equal to x square plus y square and it determines its magnitude at 3, 4. Given f is equal to x square plus y square and the gradient f is equal to I vector into dou f by dou x plus j into dou f by dou y. So here f factor is x square plus y square. Apply here. So to differentiate with respect to x, we get 2x. So I vector into 2x plus j vector into 2y. So del f is equal to 2x I vector plus 2y j vector. So here that point 3, 4 magnitude at the point. So x value is 3. So multiply 6 I vector plus 8 j vector. So take modulus del f is equal to square root of 6 square plus 8 square. So we get 100. So take the root of 100, we get 10. So modulus del f is equal to 10. And next one is prove that del into r power n is equal to n into r power n minus 2 into r vector. So del into r power n, the del is written as summation. We have to use another way, that means summation of I into dou by dou x into r power n. So to differentiate r power n, we get n into r power n minus 1. Again to differentiate r, we get dou r by dou x. So summation I vector into n into r power n minus 1. So dou r by dou x value is x by r. So summation I vector n into r power, here r is inverse, we get r power n minus 2 into x. So n into r power n minus 2 into summation xi. So summation xi means xi vector plus yj vector plus zk vector. So n into r power n minus 2 xi plus yj plus zk is written as r vector. So del into r power n is equal to n into r power n minus 2 into r vector. Thank you all for listening this video. Thank you.